Hey everybody, this is Larry. This is day 10 of the May, day 11, wow, of the May Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I'm still in San Francisco, so that my timing of my doing and also releasing the video is a little bit awkward. Um, yeah, just visiting some people and see how it goes. Hopefully today's poem is okay. Hope everyone else is doing all right. This is Tuesday or Wednesday, depending on where you are. So yeah, today's poem is 1641. Count sorted vowels strings. Given an integer n, return the number of strings of length n that consists of vowels and are lexicographically sorted. Okay. Um. Yeah, I mean, I think this is. I mean, this is going to be dynamic programming, and this is just one of those counting or what's it called, combinatoric type things. And then we can think about what it means, right? That means that, and there are a couple of ways you can think about it. The way that I think about it is, okay, um, the number of strings of length n. Actually, I forgot to plug in my headphones, so let me know about the sound quality. Let me know if this is better than yesterday's or the same or worse. And then I have my headphones here. I just haven't plugged it in because I wasn't sure about yesterday. Let me know also about the volume. Is it loud enough? Is it not loud enough? Let me know. Okay. But yeah, but this problem asks you length of only vowels and lexicographically sorted, right? So basically, you could break this down to uh, five different sub problems, if you will. Problems where you can you have length of n that ends with a, and it ends with e, ends with I, ends with o, and ends with u, right? And then of course these questions depend on what is the length, um, what is the what is what how many strings of length n minus one, right? So you can definitely do this recursively. I for these type of problems I call it I generally don't, just because I don't know. I don't think there's any good reason why it doesn't. It's just like, I think for me, choosing between top down and bottoms up, it just depends on how both familiar and also how I've done it always in the past. And you could write it top down easily. You could write something like count of maybe not easily, but with practice it'll become easier. And then you just have a like length left with, I just write L, or maybe index is a little bit better from 0 to n, and then last character is just last, right? And of course we have a e i o u, but we can also replace a e i o u with 1 or 0 1 2 3 4, because and keeping it sorted, and that should be good enough, really. And here you can think about the brute force version before you add the memorization, right? And you could just do okay, so let's just, for I in range from last to 5, right? And this will be inclusive because it'll be sorted, and then it's just, total is equal to 0, total plus or equal to count of index plus 1 I, and then at the very end return total, and then that should be good. Maybe I'm off by 1, but oh no, this is actually 0, and 0 is the actually that's not technically true. Actually what we want is one more layer of and then also I forgot the base case. I'm just getting sloppy here. Yeah, and then now you have total is equal to 0, and then for, basically we're choosing the first character, and then sum it up, like the first character being the number I, which is corresponding to a thing, and then for each of those we go, okay, we for each of those we have to start from I, because it has to be lexicographically sorted. So this is the last number or last digit or last count, depending on how you want to count it, and then we go to the next index, with the previous index being I, right? So that's basically the idea. And of course this is going to time out for bigger numbers, but I just want to show Or at least I want to see that it works for smaller numbers. Did I want it for test case? Huh. Oh, I messed up here. This should be 0i and not I0 because the first digit should be I, right, from 0 to 5. And yeah, and of course I get the wrong answer somehow. Let's see. Did I just have one off by one? I think I just have an off by one, but yeah, because I think for 2 we have 15, so I think I just have off by one. But why do I have off by one? Okay, yeah, because we should start at 1, assuming that the first character is already I, instead of starting from 0, where we don't have any character. So I think we should be good here. 1, 2, 3, 4, 5, 6, maybe even be fast enough, but that's basically the idea. I actually usually do this bottoms up just because for these things, I kind of count them in parallel. But yeah, and of course, this is going to be too slow once we go to 33. Right, this is going to time out, and then what you can do is, oh, I was wrong, huh? Okay, wow, 33 is actually not that bad, only 66. I didn't really do the math for that one, I suppose. Let's see, look at it for 50. You should still cash though, and you should definitely. I like doing the bottoms up just because, like I said, just past experience, and I think this is a little. Oh wow, huh? I didn't realize that there not that many things, and I mean, it's still too slow, and we should cache, but it's actually not that bad. To be honest, I probably have done this problem before, and I probably did it bottoms up. So if you want to check out bottoms up, well, let's take a look first. But maybe this time it'll be a good top-down way of doing it. So then now, of course, we want to cache this, keeping in mind that this takes 2 seconds. So let's make it faster. Well, the way to make it faster is by memorization. And the memorization takes into account that for every possible input of here, for one given input, you always have the same output. And therefore, we should cache it, right? That's basically the whole idea. Index can go from 0 to n. Technically 1 to n because we did it this way, but either way, it's fine. And then last could go from 0 to 5, right? So this is going to be linear time as we saw, or linear number of. So yeah, the total time is equal to time per test case, time per input, and then the number of inputs times time per input. And of course, the inputs cancel out, so you just have time, right? And the number of inputs is equal to 5 times n, and each input will take at most 4 or 5 branching factors, so that's O of one time. So in total, this will be O of n times, or O of 5 times n times, which is O of n. Of course, we have to actually do the caching, but that's logic that lets me go to the next step. Yeah, and now let us write cache is equal to actually the way that I write is that's just for teaching purposes. I have 4 times 5 for okay, fine, small n plus 1, and then cache is equal to, I don't know, none times 5 plus 1, right? And then now we can reduce this a little bit by saying, okay, if has cache of index and last, then return cache of index and last. And then of course we can now just cache this by saying, okay, we have the answer, let's cache it. It goes to true, and then cache of index of last is equal to total. And that should be good enough. Let's give it, keep in mind that took 2 seconds. Let's see if that went faster. It should be, yeah, 30 milliseconds is going to be fast enough. One additional trick, let me give it a submit first. One additional trick, oh, let's see, I've done it twice already. One additional trick I would say is keeping in mind that 771 day streak, nice. Keeping in mind that this possible inputs, there are only 50 possible inputs, right? So if you were going a little bit too slow, let's say we didn't have this caching thing like we talked about, you can actually pre-calculate the answer for all 50 answers and then just have it in an array and then return it, and then that'll be fast enough. And you could do this locally on your computer or something. Because even in the worst case, let's say it took 2 seconds to do n is equal to 50, and then you times that by 50, right? This is a very pessimistic estimate, but it takes 100 seconds, which means it takes about a minute and a half. But after that minute and a half or so pre-computation, we have the answer that is blazing fast, even faster than this. So yeah, so that's definitely a technique that you can use. Yeah, let's kind of take a look to see what past Larry did. Some having crazy allergies and that stuff, even worse to be honest. Yeah, this is how I usually do it. So I'm not surprised to see this. Definitely check out that video and yeah, for bottoms up situation. How did I do the first time? Oh wow, actually I didn't know this, but that makes sense. Actually, this is actually, this is kind of funny. I don't remember this formula, and you may have to check the video. But the reason why this is n choose four is because is it n choose four? Maybe I'm messing this up. But I actually remember how I came up with this formula at the time, and this is a year and 6 months ago. I remember seeing this one in the contest, and because I actually just solved a problem on another contest that's kind of related, and I think um, I just recognized the pattern because I think I might have brute forced some small ends, and I recognized the pattern, and then I just put it there. But this is nonsensical. I don't remember how to do it anymore because I think at the time of this contest, I did it like it came up like either that week or 2 weeks ago or something like that. So something very recently. So I was able to do this, but I don't think that's normal. I'm just curious how I did in that contest, given that I quote unquote cheated on this. Oh, that's sad. Huh. It took a while here actually. Which farm is this? Cave smallest path. Oh, I should have gotten this one much quicker. I don't know what happened here. Um, but sometimes it is what it is. I think if I did it today, I probably would have gotten it pretty quickly. But sometimes you have bad days, and or you could, you practice so that your bad days are still pretty okay, right? Like passes the bar. So anyway, that's all I have for today. Let me know what you think. Still in San Francisco, Bay Area. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.